Okay, this is actually issue number 75 for the Kaiju Engine, where we're going to be setting up the base UI code. That is, it's not the actual UI code that's showing, but it's kind of the how UI elements are grouped together and what happens when the events for hovering and exit or enter, exit, click, down, up, all those sorts of things are all just wrapped up in these functions that we're going to make, and then we'll build UI on top of that. So the first thing I did here was I brought in three shaders, and they are compiling. These are just shaders I did, previously, and I just rewrote a few of the bits to fit into this engine. So this is the UI vert shader, and the whole top part we should know from before. Same with the globals. We're going to pass out the color, the background color, because you can have a foreground background color. For example, in let's say that you wanted to do something fancy with a specific fragment shader, and you wanted those two differences, whether it was, I don't know, shading some text or something like that. Even though we have a text shader, I don't know. You can do some stuff with that. We're also going to have the size 2D, which is going to contain the size that this UI element is going to be on the screen, and its texture size. That's why it's a vec4. So its width and height for the texture is going to be in the second two parameters, which technically we wouldn't need because we would pull from the shader, but it's fine. Then we have the scissor. This is how we're going to cut it out of the screen. We could do this using uh, the the more modern OpenGL clipping rectangles. However, on older GL code, which we still somewhat want to support for, I don't know, web or something, you can do the scissor inside of the fragment shader using the scissor parameter. Now, in Vulkan, we're not going to have this. We're not going to do anything with this scissor. So that may be an area of contention in some way, as just it's useless data being sent to the instance on Vulkan. Although I think it's in the Vulkan shader code that it is scissor, so maybe it's not useless in the fragment in the vertex shader. Anyways, um, we have our passing out our texture coordinates and then our border length. Um, and this is for when we nine slice, and what's the length of our inner, our top and bottom, and left and right borders, assuming that they're all equal. This could be a vector 4 to have a unique border value for each, but say la vie, we'll leave it at that. So this is our instance data. As you can tell, it's pretty much what we're passing to the fragment shader. I've created a struct just so it's more readable on what data we're getting, and I'm pulling that struct from the texels. Then we can just use that struct. So there's just a little bit of UV stuff because we can pass in what are the UVs. So we can have an atlas texture, and we can pick what in the atlas we want to show is good for sprite sheets and that sort of stuff. So this is just setting up the UVs and then forwarding out all the other data. That's basically it for the UI vert. The UI frag, this one is not going to be used as much as the 9 slice, but this is a straight fragment shader. It does the slicing, the clipping here, and then it does the straight color from the texture and pumps it straight through, given our current thing, and order independent transparency, of course. Now, the 9 slice is the same kind of thing, does our scissor at the beginning. Here's the magic for how we do the 9 slicing for this pixel. We just process the axes. We're passing in the border length divided by the Z is the width and the W is the height of the texture. And then this is the width of the UI element itself and the height of the UI element itself. So X and Y is width and height of the UI element, and Z and W is the width and height of the texture. Because you can have a small 64 by 64 texture that's being 9 sliced up to 256 by 256. And so that's why we need those separately. And then just process the color, order independent transparency, and all that stuff. So pretty straightforward shaders. And here's the this is for a different thing. We don't even need that. That was for when I was playing around with borders, so even less code. That's best. Um, cool. So that's what makes up the shaders. Now we need to actually get the UI code. I like starting with the UI group. We need a UI folder. Let's just create a UI, and inside of it, UI or just group.go. So rather than typing all this out, I've been kind of enjoying typing it out and not having to talk during it and then just explaining what it is. So I'm going to do that section by section here. Okay, so we have a group itself. This group is, first of all, what is this group? When you have UI, you can have, for example, a panel with a button inside of it. If you hover over the panel, you can change its color, and if you hover the button, you can change its color or texture. So what happens when you have the button on the corner and you hover over, what activates the panel or the button or both kind of scenario. And so that grouping makes it so, for example, if I just want the button to change its color or do its thing, then I will do that. Or even more evident is, let's say we make a big panel that covers the whole screen. And if you click that panel, it closes some pop-up. And then you have a small panel inside that is the pop-up itself, and it has a button. If I click on the button, I don't want to click through to the panel in the background that says, hey, if I'm clicked, close the UI. So um, you only want to do the activate the click that is closest to the camera as the highest Z value. So this grouping facilitates that, and that's essentially what we want to do here. So this group has a set of requests. So if I clicked, for example, in the example I just gave, the button would have a request. So there'd be two requests, the button request and then the panel in the background request. So we'd have two requests in that scenario. Focus, I don't even know if I'm going to wind up using this, honestly. The currently focused element in the group. But it's here in case we want to use it. And then the group is going to be updating as part of the host update. It's going to go through and check its requests. Now it's going to want to do that on the late update. That way all the events can be bound on the regular update for the UI, and we don't wind up having updates going like a UI element, then a group, then the UI, because if this one was supposed to get the click, it won't because the group is being updated before it. So we want the group to happen on the late update. So before I go and fill out a bunch of the stuff, I do want to stub in the UI, the UI interface and the event type stuff. So we're going to have UI.go, and then we're going to have event.go. So for the UI, I'm just going to drop this in and we'll fill it out in a minute. And for events, I'm actually probably going to fill this out. So we're going to start off with setting up an event type, and these are the events that I have currently available. We have invalid, enter, exit, click, down, up, miss, which happens when you click and miss it, scroll, rebuild, destroy, and change. And then this is just so that I can make an array of these events very easily. So we have an event ID, which is going to be whenever we bind to an event, we can know which event it is given its ID. That just is something that we've done in other places, like the update ID, that sort of thing. And then this is going to be an entry inside of the event, which is going to be the ID of the entry and the function that it's going to call. Okay, so now we have the UI event itself. This is just the ID, it's just going to increment to give us the next ID, and then a list of the events for this event. So if this is a click event, that's going to be a list of click events. We have a helper function to check to see if there are any events in here, and is empty. We have a way to add an event with a call. So you give it a call, it'll return the event ID. So it'll get the current ID, increment to the next ID, append that event, and return the ID that it pulled. And then we have the remove, which given an event ID, it's going to go through and find it. When it finds it, it'll delete it and then exit out. And then, of course, execute, which just goes through and executes all the events. The order in the events don't matter. So that's just something to keep in mind. So back over to the group now. We've got those errors cleaned up and we'll continue on this. Okay, some more of these functions. We're going to be able to add the request. So this just allows us to say on this is the UI element that is making the request, and this is the type of request we're making. Just make sure that it's a valid request, and then add that request to the list of requests. And this is just a helper event to why do I have this? I have two. Group add request. Request event. Add request. I kind of like, now that I'm thinking about it, I kind of like request event more than add request. EVT type. Let's change this to E type. Anyways, so we have the set focus. This will just allow us to focus on an element. Let's see, set focus type miss. So this is just for when we want to click to add that focus. Like I said, I'm still thinking about if I want to do the focus thing right now, but we'll have it here. I don't think we're going to use it right now. We'll see. Then we're going to have the attach and detach for the group. This is just going to make it so that we can get the host, we can go to the late updater and we can add a late update function to every late update. We're just going to say if the entity that this grouping belongs to. I think I don't want to attach this to an entity, honestly. Let's just make it, just go through and do the late update all the time. Sounds good to me. Then we can remove the, we can detach it or remove it. We don't need this. Cool. So now we have the ability to request events. That's stub function for set focus, and then essentially enable and disable the late update. And I don't know why I want to call it attach or attaching the group to the host and detaching it. I don't know. Might rename it at some point. So now we are going to need to have these functions. Execute event we'll come back to, that goes in the UI, but we definitely need this late update. Okay, so let's ignore sort requests for now. Inside of the late update, if we have requests, then we are going to sort by that sort request function. So that essentially means that we're going to go through all of the groups and we're going to say, return me the UI element that is closest to the camera, essentially. So we're sorting by that z-axis, and we're just timesing by 1,000 just so that we can have we don't have like a 0.0001 kind of scenario, and we can broaden that out a bit. Yeah, so it sorts those closest to the camera first. Now we make a list of available requests as a bitmap, so we don't use up that many bytes. If there's like 1,000 requests, we're not using 1,000 bytes for booleans. So then we're going to go through the requests, take that first request we're on. We're going to say if that type of request, say a click event, has check. Oops, this might be not equals. B is not equal to 0. Okay, so these are all being, when we new up a bitmap, it's all zeros. So we can say, I might invert the logic. Let me see. Actually, this makes it more readable, so I'm just going to make a new type of new set, new enabled. Nah. new canoe, new um, assigned. I can say new true. I guess that's a good one. Then we'll say a bitmap return B for B. Cool. And that works for me. So now we can say new true, and now available. So all of the event types are available. If it's still available, we're going to set our should continue to true. For the type enter, exit, and miss, we're going to run execute, and we're not going to do anything with the return. We're just going to execute it because hover, exit, and miss are things that really in the group should all activate even when they happen. So like in that scenario, when we hover over the corner with the button in the corner, both the panel and the button should get the hover enter event or the enter event. However, for things like click, mouse down, mouse up, and scroll, those do not. So we're going to say if we did execute any events, then we should not continue. And then we're just going to do available assign should continue there. And then at the very end here, we clear out the requests. So essentially, if we went through and we said we did click, it said should continue as false. It assigns it to false. The next time it comes through, it says we're checking the event type click. This is going to be false, so it's not going to do it. So the closest thing to the camera is going to do the capture for these 4 events here. Okay, now we need to go and set up these functions for our UI. Okay, before I set up the UI, before I forget, we're going to do shader data.go. And this is going to contain that stuff we saw in the fragment shader. UI dot, or sorry, the vertex shader. We essentially need this structure here. Okay, so here's that structure, just mirroring what we have in the vertex shader. This is the size function that's required for shader data. And this is a helper function just so that we can set that size 2D for the width and height of the UI element and the texture width and height. So this is just a helper to set that. So now we can go back to, let's get rid of all this other stuff, bitmap group, and now we can focus on the UI. Okay, so I'm gonna set up a bunch of functions here for what makes a UI, at least the interface of it. So without any code, this should be mostly self-evident. We have an entity, so every UI element has an entity attached to it for its placement, and we have an ability to get that. We have an ability to execute an event given the event type. We have the ability to add an event given the event type and the function. Same thing with remove event. We're going to update the UI. This has to happen on the regular update, not the late update, as we discussed. We have a way to set this UI dirty. We'll go through the different dirty types in a moment, but that's what this dirty type is going to be. Layout, we'll get to that. That's going to be a pretty big amount of code, file of code for laying out things. So you can anchor to like the top left, top right, top left, right, middle, bottom left, bottom right, bottom middle. And then you can also stretch across the top, stretch across the left, or down the left, stretch down the right, stretch across the bottom, and stretch it from the center to the corners. So support for all the math that makes up those will be in the layout. Here's that shader data. We can get access to it. Generate scissor, the lowercase functions are functions that we just need inside of the package here. So we need to be able to generate the scissor, check if it has a scissor, because not all elements need to have a scissor. Though pretty much most all of them will, we should be able to turn it off if needed for some kind of UI effects. we want to be able to get the host. I called it self-host because likely the video is going to be, or the video, likely the variable is going to be a lowercase host, and so that'll be kind of weird. We have the ability to get what dirty type we currently have. We have the ability to set the scissor, and we have the ability to clean the UI. So rather than waiting for the next update cycle to update this UI, we can do it immediately. And that's helpful for, let's say, we're in the middle of an update or late update and we generate a bunch of UI. Well, if that UI renders immediately, that frame, it's going to look all wonky. It's going to be, none of the layouts going to have been updated. So it's going to be like small or in the corner or weirdly shaped and sized. And then you'd see that for a flash in one frame, and then the next frame it would all be correct. So clean just allows us to clean it right now, do the layout, set it up for this render pass. We don't want to do that all the time because it's not necessary, but that's why we have this function here. So let's set up the dirty types. Okay, so these are the different types of dirties we have. We have no dirty. Um, it has been cleaned or it's current. It just got generated, so there's nothing dirty about it. We have the layout has made this UI dirty, so the layout changed. Say the screen size changed or something like that. Um, the UI has been resized, the UI has just been generated, the UI has been regenerated. So as part of the update, it calls generate to say add new children or some kind of weird thing, or maybe it's all messed up and or you're going from portrait to landscape and you want to regenerate that. So it's going to have a regenerated. Color change is a pretty common one. The scissor changed. The parent has changed, so we've parented this UI element to a new parent, so we need to say that it's been dirty by reparenting. And then essentially copies of the top ones, but for when the parent does something. So if the parent layout changes, then the children should know, hey, I need to change due to my parent's layout changing. And that's essentially what this stuff is. And those just, it's turtles all the way down for that. So the child would have parent layout if the parent's layout changed. So those are our different dirty types that we're going to work with. Okay, so this is going to be our base UI structure that we can compose into other structures or just use and work from it. So the UI base is going to have the host that we talked about. It's going to have the entity that it's attached to. It's going to have the list of events, and this is going to actually be a known value, event type end or something like that. What was it? Event type end, yeah. So this is a known value. We can actually do this to get some compiler optimizations. The group that this UI element is assigned to could be none. The scissor, where we started dragging from, where the down position was, the layout, the dirty type, the shader data, the texture size. This is just so we can pass it into the size 2D. So it's good just to keep it. Whether we're hovering, whether we can't miss it, whether it is currently down, I just clicked, whether I'm currently dragging it, if it was last active, and if I have disconnected the scissor from it, so turned off scissoring for some kind of special effect. These are the values that I found that I needed when I have designed UI system, and one of the programs that I created, the pixel art program, is nothing but UI, so it has quite extensive use with just these I don't know what to call them, primitives. Okay, so being that we are not really going to just be calling new on this UI to get it, we're probably going to be composing it as part of other structures, composing it into other structures. We need an initialize function for it. So given it and these values, we're going to go and make the things we need to make. So this no longer needs to happen. So we're going to assign the host. We're going to create a new entity on the host. And then we're going to add named data to to the entity. So we're going to say this UI is part part of the named entity, and the UI base should be the first structure, first composition, or first element in the composed structure. So passing itself, because it's a pointer, is good enough to get whatever derivative type it is without causing any craziness. Or perhaps it will, we'll find out. So before I continue, I'm going to add um, this constant in, but we are going to do it in a helper file, entity data.go. So this is going to be the UI name, go figure, it's just UI. Then we're going to have the ability to get the first UI off of an entity. So given an entity, find the first UI. It's just going to go through, get the name data list, and return the first one it found. And then same thing, except we can get all on the entity. And those will be properly cast before the return. So just a couple helper functions with that. So that will make that happy. We're going to drop in a bunch of getters, getting the entity, getting the layout, does it have a scissor, get the self host, what is the dirty type, and the shader data, fulfilling a lot of that interface. Adding in some event functions so we can execute an event given the type. We can add an event given the type and the function that we want to add. It's just going to go and add it to that type, and we can remove an event. Okay, just one function this time because it's a little bit of a doozy. Set dirty, we're going to say what type we want to pass in. There's certain conditions that we don't change the dirty on, or there are only certain conditions in which we change the dirty on. If it's not currently dirty, if the parent is dirty, so we're making this one extra dirty because it hasn't really done anything itself, it's just changing because of its parent, but now it's changing because something of itself. If the type is generated, that's always going to be dirty, no matter what type of dirty it currently is. And the same case for the regenerated. So the dirty type, we assign the dirty type, and then we have to go through the children and deal with their madness. And I suppose this should be less than dirty parent, because its own dirty options are the more high priority one. Let me think. No, because I think the parent ones are important because it could just change around the screen or something like that, something drastic. So if a parent has changed, then it likely is almost like a generated. So we're going to leave it like that. So we're going to go through the children. We're going to find all of the UI on the children. Likely it's only going to be one per child. Going to go through those. If the dirty type is none or the dirty type is greater than parent, we're going to do this portion where we're just going to say if the dirty type is less than whatever the parent is, we're just going to set dirty equal to dirty type parent plus what it currently is, and that's just going to essentially say if it's layout, then it's now going to be parent layout, something like that. I don't know. Seems fun. The actual explicit type doesn't matter too much right now. Maybe it will when we start debugging, but dirty is dirty, and the only thing you could do is clean it. Otherwise, we just set the dirty type. Okay, so that's the dirty function handled. Now we're going to do the generate scissor and the set scissor. So generate scissor is basically saying if there is a scissor, and I think we have a has scissor boolean here. So it has the same thing. So I've just typed in myself twice. I could say if UI dot has a scissor. So if it does not have a scissor, we're going to generate one. So we're going to get its position, we're going to get its scale, we're going to get the scale, we're going to get its bounds, and then we're going to say that bounds is now the scissor. When we set the scissor, we're essentially getting that effect 4 bounds, left, right, top, bottom kind of thing. Although this is, I think, width and height. No, let me see. X minus size dot X. No, this is left, top, right, and bottom. If the scissor is disconnected, we're not going to connect it. Otherwise, we're going to assign the scissor and then go through the children and set the children's scissor to our scissor. So let's imagine that we had a panel that was 100 by 100 pixels, and then we had a child panel that was 100 by 1,000. That child panel is going to go past the bottom of the parent, and we don't want to be able to see that. It should be clipped to the size of the parent. So the parent's 100 by 100, so the child is clipped by 100 100. And then we can scroll that child around inside of the panel. That's the concept. So the children are always scissored by the parents first and foremost, and then by themselves otherwise. And then we're going to set the shader data for the scissor, and then we're going to say that we have dirtied this thing. The scissor has changed. Now, before we get too far from the dirty stuff, we'll just put these guys in here. I had it down there, and I decided I'm going to paste it up here. So we're going to have the clean, which is just going to be, we're going to update the layout. Then we're going to execute any rebuild events. We're going to set the transform dirty because we've probably changed the layout itself may have changed the size. I don't know. The layout should actually do this ourselves. So I made to do layout should do this. So remove if so. We're going to set the dirty, and then we're going to set this. And the reason this is red is likely because this interface hasn't been completed yet. Yeah, there's no update function. Then we have clean parent, which is called when a parent has been cleaned. So when we clean, you'll see the clean is called here. So if there is a parent, we're going to call clean parent. So it's going to go up the chain. And then we're just going to go through all the children and clean them. So clean is just kind of going to do the whole hierarchy there of cleaning. Okay, so that's going to be those guys. We have a request event function, which takes in the type of event. If we are in a group, we should tell the group, hey, I'm requesting this event. If we're not in a group, we should just execute the event immediately. There's no grouping to kind of go through. So it's just a floating UI thing that needs to be executed. Okay, and now for our last bit, which is going to be the update. We're still going to have these errors because the layout doesn't exist, so the structure is invalid at the moment. So we are going to do update. That's going to get our cursor. We're using cursor, not mouse. If the cursor is moved, we're going to get the, this is a helper function, pointer pause. I guess I can call it cursor pause. Oh, right, errors. Let's just paste that in there. Cursor pause, cursor pause. Okay, so we're going to get the cursor position relative to the UI. So we're going to get the UI camera position, and then we're going to do cursor screen position. We're going to add in that camera position. This is just because we may have the UI camera moved around for some reason, for some effect. So it's just going to consider that. We're going to see this contain checked is just going to pass in the UI entity and see if the cursor is contained within that entity. Very straightforward. Get the cursor, mouse position, cursor. Isn't that what this is for? Cursor position, UI cursor position. Oh, no, because we're passing in the cursor. Okay, so we're getting the cursor position. We're checking to see if the transform contains this 2D point. MP stands for mouse point. I didn't know what else we would call it. CP. Sounds like copy, whatever. If it's contained and it has a scissor, we need to determine if it's outside of the scissor, because it could be in the entity, because remember that child panel could be 100 by 1,000. So my cursor could be in that 1,000, it could be at like 500, but it's outside of its scissor range because it's scissored by the parent, so it should not count. So we need to check for that scissor. Now, if we're not hovering and we're contained, it's going to say hovering is true. We're going to request an enter. Else, if we are hovering and it's not contained, we're going to say the hovering is false, and we're going to request the exit event type. That brings us back up to here. So if we are down on this element and we are not dragging it, we're essentially going to determine if we're dragging it. So if we've moved by some threshold, uh, in this case, I'm going to be using 4 millimeters, then that's going to be considered a drag. Now, if the cursor is pressed, left mouse button down, stylus is down, your finger is down on the screen, we're going to do the contain check again because this one was just for moved. So if we're pressed, we need to do the contain check. And then we are going to check to see if we are hovering and we are not currently down on this. It's going to call down, and it's going to figure out what the down position is, request the event type down, and can't miss is true. So essentially, what we want from this is, let's say that we had a button right here. If I clicked in the button, moved out of the button, moved back in the button, and let go, that should count as a click. If I clicked in the button, moved out of the button, released, that should not be a click. If I clicked outside the button, moved into the button, and released, that should not be a click. So we're looking for that sort of stuff. Likewise, release is going to have the same kind of thing. If we are hovering over it, we're going to do type up. If it was less active, if it was down, we're going to change these both to false. If we have a drag, we're going to do the dragged stuff. And then we're going to say if we are hovering and we're not dragging, as in I clicked and I dragged and I let go kind of thing, like the UI element can be dragged and it has been dragged, then it shouldn't count as a click, essentially. So only if it is hovering and it's not dragged do we do a click. Else if we're not hovering and we can't miss, we're going to say, or if we are not hovering and we not can't miss, then we should do an event miss type. So remember, we set can't miss up here to true. That means if we clicked on a button, moved away, and released, that doesn't count as a miss on the button because we actually started to click down on it. And then we just reset can't miss. Here's our stuff for if we're scrolling. If we're scrolled and we're hovering, then we're going to do a scroll event. And if we are dirty, we're going to do a clean at this point in the update. Cool. And then we're just setting the last active to if the entity is currently active. All right, so that's going to cover all that madness for the UI. Now for the star of the show, the layout. So this one I might go a little bit fast on because quite a few parts of it is just rehashing of other things with a slight change because we were doing anchor left, now we're doing anchor right, so we change how we're doing the x-axis, addition and subtraction stuff. So a lot of that is pretty redundant. So all right, here we go. All right, I'm going to start out with a big old block here, and before I continue, I'm going to come over here and check out what are the. Yep, that's a fine error. Just make sure I don't have any. Let's see. It's not implementing UI. It's probably because the missing method self-host. I think that's just, it is missing self-host. How's this spelled? Oh, self-host. Self-host. There we go. Okay, now it's just that update. Okay, here we go. We have an anchor. We have positioning. There's a lot to a layout because you can have margin, you can have padding, you can have borders, you can have floating layouts, left, right, all that sort of stuff. So there's a lot going on in here, and I'm pulling it from again, existing functional stuff, so there's a lot. And going over every little detail is complicated, so I'm going to hit the high level stuff here. So we have just some helper functions here at the top, some conversions for anchors. So before we go into that, let's see what an anchor is. Let's just take these guys and stick them up here. We have anchor top left. That's where we start, 1 plus iota. Anchor top center, anchor top right, anchor left, anchor center, anchor right, anchor bottom left, anchor bottom center, anchor bottom right. Those should all be self-evident. These are just all the corners from top left to bottom right. Then we have stretch left, stretch top, stretch right, stretch bottom, stretch center. Those are the different kind of stretch layouts that we can have. Next, we have what kind of UI positioning we have here, and this is similar to what you do in CSS. You have a static positioning, absolute positioning, fixed positioning, relative positioning, and sticky positioning. Now we're going to go over these converts. They're pretty straightforward. We're going to convert to top. Essentially, if we are bottom left, we're now going to be top left, right? Etc., etc., etc. Convert to bottom. If we are top left, we're now going to be bottom left. Same thing for convert to left, convert to right, and convert to center. Convert to center may be a little bit different. Essentially, if we're top left or top right, it's going to be top center, essentially. So now we have some helper functions to say, are we on the left, are we on the right, are we on the top, or are we on the bottom? And this is just checking anchor left, anchor top left, anchor bottom left, and anchor stretch left, for example. Similarly on all of those. Now we come to the big boy, the layout, structure for all of this math and madness. We're going to have the offset of the UI element, the inner offset of the UI element, the local inner offset of the UI element. This is just other ways to offset it, where you're going to use these in special cases. If anyone is feeling frisky, I did in my previous engine make it so that CSS can control the UI. That's not something I'm interested in focusing on right now or anytime soon, or even copying that over. I think that is going to overly complicate the simplicity of the UI, and that's something that can be added on later. So these are going to be here for that availability, and they will be functional for that availability. And you can obviously set these without CSS. You can do other stuff with it. Now we're going to have the left offset, essentially, top offset, the right offset, and the bottom offset. So these are also going to be for the stretches. If I have a stretch left, boy, this is complicated. Okay, if I have a stretch left, that means it's going to be over here on the left, stretching against the left side of the window, right? So our left is going to be 0 if we're up against the left-hand side here. Our top is going to be 0 if we're against the top. Our bottom is going to be 0 if we're against the bottom. And our right is going to be 50 if it's 50 pixels wide. So right will be 50 in an anchor left scenario. Right will be 50. Okay? Take a wild guess. If it's stretch top, if my top is 0, I'm against the top. If my bottom is 50, then the height is essentially 50. And if my left is 0 and my right is 0. Of course, if I change that and I said my top was 25 and my bottom was 50, right? So this is going to be 25. And the height, if the bottom is not 50, if the bottom is 75, then this is going to be 50. And if the right is 10, then we can just bloop. And if the left is 20, that's the offset from the stretch side. Same thing for right, top, bottom, center. Center is going to be the offset from every side. So X, Y, ZW is going to be that. Left, right, top, and bottom are going to be that. Okay. Z is the position on the Z-axis. How close to the camera? What's the layout on the camera. So if our entity for our UI element is at 0 on the Z, my layout can be 1 at the Z. So it'll be closer, 1 closer to the camera, 1 unit closer. This is going to be our anchor point. So obviously if we have an anchor point in the top left, it would rotate around the top left corner. This is the actual pixel size of this layout. This is the UI element that this layout belongs to. So they have basically a bidirectional understanding of each other. We have the anchor where this is being anchored. We have a couple of helper variables here for the layout function that's to run and the anchor function that's to run, and those are going to be derived from our anchor. And so one is going to be for stretch, and the other one is going to say whether we stretch or not, or whether we're floating or not. This is going to be the bounds of this UI element, and the bounds include the parent. We have access to what the last parent was so that we know if it changes in here. We don't have to pass it around and do a bunch of weird stuff. It knows its size, its wheel scaler, the border, the padding, the margin, the inset, the positioning. These are all the CSS stuff that we have access to that you really don't need to use. I didn't use these or these, or these two at all in the pixel art program. Offset is the offset on the screen. So if it's a floating panel and it's centered in the screen, if the offset on the X is 10 pixels, it's going to be to the right 10 pixels. These are just some functions that make it much easier to run externally. So whenever some thing happens, the layout changes, we can run a function, an additional function to play around with the UI. That's helpful for the CSS stuff. Again, probably not going to use it as much right now. And then a Boolean to say whether we currently need to run the functions. Okay, we're now going to have that add function function just for setting up those. And then we're going to have anchor, top left, top center, top right, left, center, right, bottom left, bottom center, bottom right. These are the anchor functions. Notice the self layout width, height, and size here is going to match to this right here. So we're going to assign one of these functions to the layout anchor function to be called. That way we don't have to have a big switch statement for all these guys in the update. We just call the function that's been assigned. Okay, so now the layout functions. We have a floating layout. We have a stretch left, stretch top, stretch right, and stretch bottom, and stretch center. These are the anchor functions for stretching. So we have anchoring for floating, and then we have the layout for the floating. This is the math to do that layout. Then we have the anchoring for the stretching, which mirror these kind of guys up here. And then we have the function for the layout for the stretch. Notice this function, the layout stretch, and this function, layout floating, match up to this function here, the layout function, and for the same reason as the anchor ones. Okay, so now we have some preparatory functions. We have one for the layout. We have the prepare function, which is going to do run those functions if we need them, and then it's going to set the bounds. Setting bounds just goes through the parent, goes through itself, does the world scaling, does all that stuff, the transformations of it, determines what is my maximum bounds given my parent and myself. If the parent has changed, we're going to do this stuff. And then we have an initialize function, which is going to do an initial update for the layout. Okay, set offset, important function. This is for the primary offset that you'll use all the time for floating panels. This is offset kind of floating around on the screen. The rest of these functions are the helper functions for the CSS stuff. So inner offsets, local inner offsets, yeah, that's what all these are. So look at those as you will. Those are not likely going to be used. I'm not going to be using them anytime soon, but they're there to kind of investigate and learn about. I have tested them though in the CSS stuff. Okay, these next set of functions are back to the important ones. Set stretch. This just sets the stretch, left, top, right, bottom. Very straightforward. We can set a stretch ratio, so we can do like 25% of the screen, or not the screen, 25% of the parent. And a UI with no parent, the screen is the parent. So we can set that to a ratio rather than a fixed pixel size. We can scale the UI. We want to scale UI using this function and not the entities transform. And I'm going to repeat that. We want to scale using this function and not the entity transform. And we have a scale width and a scale height function as well. Okay, we've got a bunch of getters here and there. 3 functions for future use: setting the border, setting the padding, setting the margin. You can use them if you'd like. Padding may be actually pretty useful, so I may wind up actually using that one. I don't know about margin. I don't need that complicated UI typically. And why not? Let's just go through the very last. Let's just do all the rest. So the anchor 2 is just a function where we can pass in what kind of anchoring we're doing to this UI element. And this is where the big switch statement is, technically. I don't know why I have this as if else. Bruh. Do you not switch? Anyways, this just, no difference. This just sets those functions. So it just sets a variable to which function to use. For example, if our anchor position is anchor center, then we are going to set the anchor function to anchor center and the layout function to floating. However, if we are going to be stretch center, we're going to set the anchor function to stretch center and the layout function to stretch. Okay, then we just assign those 3 variables and we say that we are dirty on the UI. This is a helper function just to determine if the parent has changed. When we update, if there is a layout function, which there should be always, we're going to prepare. We're going to execute the layout function, and if it has a scissor, we are going to generate the scissor. So this update is not an update that happens every frame. It is updating the layout itself. We have a helper function to get the Z, and we have a helper function to set the Z. Then we have a helper function to set the positioning, and then we have a helper function to get us the content size for this layout. And with that, our UI is green. Now, this has already been like an hour, so I'm going to set up the actual UI in future ones. The panel is going to be the most important, and it's going to be the longest because it has scrollability. So you can add children to a panel, and you can scroll the panel around left, right, up, and down. The children are all clipped inside of it, and so the panel is probably going to be our most complicated UI, and other things are going to be composed of panels. So I'll likely start with the panel next, and we'll actually be seeing the UI on the screen, and that's when we can come in and debug anything I may have messed up with on this layout or in the UI code. So, all right, sorry for the long one of kind of just explaining the code, but imagine if I typed all this out. Whew. A lot of UI is a big complicated part. Now, I do want to touch on the point I noticed at the end of the video, and that's a weird place to put it because no one's going to be watching this, at least this far or at all. Excuse me. But I do not want to do MVVM stuff. I don't want to overcomplicate the UI. I want my UI to be as close to Unix as possible. In Unix, you make one program that does a small amount of stuff, and you compose it with other programs, and it's beautiful. It's probably the most beautiful design pattern in existence, and I want the UI to be the same way. We have this base kind of layout stuff, and that's essentially what the UI is. It's a bunch of events and a bunch of layouts, and then we can compose very complex UI if we need to out of just these primitives, and that's hopefully what we can achieve here. I mean, I was pretty happy with it in the pixel art program, and that one had a lot of UI and a lot of complicated UI, and it composed, at least in my view, very nicely. and I didn't need MVVM or event bindings or any of that stuff. That just is way overcomplicating everything. Cool. All right. Well, see you in the next one.